So at this given point, we are going to look at this particular question. Whereby you can be told to work out question to do it planning, analysis, and evaluation. This is basically paper. Nipe hiyo simu. So if you are given a question on planning and evaluation, one of the things that you can be asked is a question to do with so you'll find that you are told to work out, and question 1 is about question 2 is about evaluation. You try to use the data that is provided so that you can be able to complete the table, and in the event you may be told, you have to be told, you'll have question to do with uncertainties. And I would just like to take you through that so that we can be able to see in the event you are asked, what are you supposed to do in a question like this? So let's go to the first part, and you can see here we are given a series of different resistors, and we are told that the in experiment is repeated by changing the number n of resistors. So a graph of 1 over I against 1 over n is plotted. So in that way, what are you supposed to do in such kind of a scenario? So you are supposed to find the gradient and the y-intercept, so which means that we need to rearrange whatever equation that is provided here so that we can be able to find that. So the equation you can see here was the equation was E is equals to, what I'm going to do, I'm going to open the brackets, and then this is going to be basically E is equals to IR over N plus IZ. And then since I'm going to plot a graph of 1 over I again and 1 over N, so I'm going to divide by this I everywhere, divide by this I, divide by this I, and divide it here. Of course, what we're going to remain with, this and this will cancel out, and this and this will cancel out, and we shall have E 1 over N is equals to R E 1 over I is equals to R over N then plus Z at that given point, because we want it to be in the form y is equals to mx plus c. It will mean that at that point of time I can divide by E all through so that I can remain with 1 over I. So I'll have 1 over I, 1 over I is equals to R over E, 1 over N, then plus Z over E. So if you can see this equation that we have, this is the form Y is equals to MX plus C, because you are told 1 over I is on the y-axis, which is basically this part that we have here, and also 1 over N is the x-axis. Then it means that this part that we are having at this point, this one here, is basically the gradient of this equation. So we can be able to say this is the gradient is going to be R over E, and the y-intercept is going to be Z over E. So that's what you are supposed to do at that given point. If we move to the next question, here is the question where you are supposed to complete the table, and I believe always there has to be a question whereby you are going to complete tables in this exam of tomorrow. Let me just take you through how we're going to complete the table. And remember, we are told you are going to include the uncertainty. You are going to include the absolute uncertainty for 1 over I. So we have to include the uncertainty. There are a few things that you need to remember. If you are finding 1 over I, we are going to check what is the number of significant figures here. So a few things that you have to have in mind is that the calculated value should have the same number of significant figures as the raw data. So which means that we are going to take 1 over 5.5. So 1 divided by 455. If you put that in the calculator, you are going to get the answer being equals to what? And also remember, we have mu there, so which means is going to be 1 divided by 455 times 10 raised to power negative 6. So if you just put that in the calculator, can you check what's going to give you? If you try to evaluate that, because you see the units here are having mu, so you can check 1 divided by 455 times 10 raised power negative 6. That's going to translate to what? This is going to give you 21.90. So if you are going to, this is 97.8, but we can, if you round this, it's going to be 2200. But if you look at this here, meaning we're going to write this as 1, 2, 3. So you're going to shift this 3 steps. So you're going to have 2.2 times 10 raised power positive 3. So meaning that what you're going to remain with here is 2.20. Then we're going to find the uncertainty. So let's complete the table first. And that is going to be 1.90 plus or minus. We're going to have 1.72 plus or minus. You will have 1.57 plus or minus. You shall have 1.46 plus or minus, and then you have 1.31 plus or minus. How do you find the uncertainty? So that is another question that you're going to ask yourself. How do you find uncertainty? We're not going to find uncertainty the way we used to find uncertainty in year 12. Here, to find the uncertainty for this, we're going to say uncertainty is going to be average value. I'm going to use uncertainty is going to be equals to 1 over V average, which is basically this, minus 1 over V minimum, all, yeah, minimum. So I'll take the average value. So the average value is basically this, and the minimum of this is going to be 1 over minimum value of this is going to be 1 over 455 plus 5. That is going to be 460. So it will be 460 times 10 raised to power negative 6. So if you work it out, so it will be 460 times 10 raised to power negative 6. And that's going to be basically 2173. So with that 2173, this is going to be 2173. Then you can see now we are expressing in standard form times 10 raised to power 3. So this is going to be 3.173 times, sorry, it's 2, so not 3. 2.173 times 10 raised to power minus positive 3. So we can be able to say this is going to be 2.17. So if you subtract here 7, 2.2, and then we are going to have our uncertainty as 0.03. So the uncertainty for that part is going to be 0.03, which means that you do the same. So what you need to remember is your average calculated value minus the minimum calculated value, which is going to be that. So if you work out the uncertainty, you'll get the uncertainty for this one will be 0.02. This next one will be 0.02, 0.02, 0.01, and then lastly we have 0 plus or minus 0.01. So the next thing that you're going to do is to plot the graph so that you can be able to work out the gradient line of best fit and the line of worst fit. So you need to know how to draw the error bars. I'm tired.